This is the second installment of our new series, Foundation Models for Embodied Decision-Making Agents. In other words, foundation models for robots, or how we can think about robot AI in this new area of transformers that have enabled this amazing proliferation of artificial intelligence products across the world. The reason we started this series is I think there is a need to fill a gap between the research community, the actual technology implementers, in other words, the engineers, and the investment world. I think the investment world doesn't quite understand the magnitude of the impact yet. I mean, I shouldn't say that really. I mean, the markets are obviously pricing things, such as NVIDIA and other companies to very high levels, but I don't think the narrative is there. So we're trying to fill that gap and help ourselves and our listeners understand where this technology is going. So what is a foundation model? A foundation model is based on what's called a transformer architecture. It's a model that learns in an unsupervised way from a lot of unstructured data and kind of compresses that data into a database, or call it a knowledge base, or a memory, or a brain. Think of it like if we take GPT, a generally pre-trained transformer, which is the base for OpenAI's ChatGPT. So if we take that, for example, we look at it and we say, we tell ourselves, okay, what is this, right? We ask ourselves, what is this? And the answer is, it's the compressed knowledge of the internet. It's embedded in vector language, or in some sort of language that computers understand. It happens to be vectors. So think of it like that, like you have, let's say, a text about the weather in California, and this text is embedded, it's represented in vector form, and then the machine can do something with it. And if you train it in a clever way, which happens to be what's called masked autoencoders, which means it's just a certain technique of how to train a machine based on that knowledge to memorize that knowledge and then reproduce that knowledge and potentially generate new knowledge. Now, we're certainly not at a point where we can generate new knowledge at scale, but we can at least summarize and reproduce knowledge that has been there in more useful ways, or in more maybe more humanly accessible ways. And that has been the really great advance of generally pre-trained transformers, or GPT. The beauty of this architecture is that you can represent unstructured knowledge. So you solve two problems here. One is there's been for years now, there's been a question of how unstructured learning can happen. Unstructured learning is not supervised learning. So you have just a bunch of data and you look at it and you try to make sense of it. And that's what this generalized pre-trained transformers have been able to do. They've been able to compress knowledge in an unstructured way and make it reproducible. And what's really powerful about it is now, if we add reinforcement learning with human feedback, which is how ChatGPT was trained, and also Mistral is trained, the Claude model, or Mistral, the model which has Claude as a user interface. What they have is this ability to interact sort of in a human way with people, and this is really powerful. So now, the reason we started our series, Foundation Models for Embodied Decision-Making Agents, is because we think that the same idea can be used for robots. And we're gonna use the word robots in the future as embodied decision-making agents. So this could be a car, this could be a humanoid robot, this could just be an arm, this could be anything that is embodied, moves around in nature, and has to be able to find certain tasks, to execute certain tasks. And today we're going to talk about the Tesla robot, the car, not the Optimus, it's the car. And we're going to talk about three things here. One is we're going to talk about what shadow mode means, why shadow mode is so interesting for learning. We're going to talk about why end-to-end is so key. And then lastly, we're going to tie it together and discuss a statement by Tesla that was made actually yesterday in a call where they said that, in fact, the Tesla engineers at this point are mainly focused on compute. And that's very good news. And I'm going to explain why. So let's start with what is shadow mode? Why is shadow mode so important? Shadow mode is the following idea. Let's say you drive around in your Tesla and Tesla monitors your driving and runs a model next to your driving. So pretends that it's driving by itself. So the Tesla robot pretends to be driving. It's obviously not driving, but it pretends to be driving, and it tries to and you can, you're driving and the robot's driving parallel. So it sees the same thing. It has, the cameras and sees what's going on, and it can now infer from the log driving whenever there's a mismatch between what you did and what the model wanted to do. For example, you're at a crossroad and you turn right and there's a person crossing the street and you stop, let the person pass. And the model was thinking, maybe I shouldn't even turn right. I should wait till the person passes and then turn. So that's a discrepancy between what you did and what the model wanted to do. This gets uploaded to the mothership, Tesla headquarters. They analyze this data and they fine-tune the model or train the model on situations like that to do what the human did. The Tesla spokesperson yesterday said something incredibly interesting, which is they said that the power of FSD V12, version 12, is that it drives a lot more like a human. And we discussed this in a prior episode. We believe that the problem statement of FSD should not be to drive as accurate as possible or even without accidents and all that. It shouldn't be that. It should be, first and foremost, that FSD drives like a human. Because in our opinion, that is the most important thing for adoption. It's not even how accurate it is. It's not even how, how efficient it is, for example, or things like that. What it really matters when push comes to shove is that it drives like a human, at least for a transition period. We could be in a world 50 years from now where cars drive like robots, and human driving is something from the old times. Maybe a little bit like, handwriting. Handwriting is beautiful and we still do it, but it's a relic from the past. Nobody writes with hands anything more serious than a postcard or a love letter. Not that that's not serious, but you know what I mean. Like any business type stuff, any documents, everything is written with machines. But there was a transition period. There was a transition when, I used to work in a newspaper in the 90s when there was still a lot of handwritten editing. That doesn't happen anymore today. So in the same sort of spirit, we believe that there is going to be a transformation from human driving to robot driving, and that the robot, in order to do that transformation, for now at least, should be driving like a human. And that's what the problem statement is, and that's what Tesla actually aims to be doing. So this brings me to the second point I want to discuss, which is V12, and why end-to-end is so important. Now, end-to-end is important for several things. What it really means is that you optimize one pipeline and that the problem statement is photons in, actuators out. That's, in a nutshell, what it means. And I've been working on several research papers that actually tackle this similar problem in many different ways in robotics. For example, just recently I read a paper from that was accepted at NeurIPS this year or last year in New Orleans, where they use an embedded sort of, they use a hierarchical model where they use language for high-level semantics. So things like, go over there and pick up the broom and clean the room. But they also train the robot on low-level semantics and represent the low-level semantics to the actual skills, which is walking, pick up, clean. Those low-level semantics are represented in what they call action space. So think of it like vectors that represent that skill. And then the semantic instructions, go over there, pick up the broom, and clean the room, are concatenated with the low-level representation of skills to make sure that the robot can actually go there, it has those skills, pick up the broom, it has those skills, and clean, which means literally clean. And maybe that cleaning also has to be subdivided a little bit. So in that realm, I think end-to-end learning wants to optimize a certain task in a one-shot sort of neural network type optimization. There are no rules, there are no exceptions, there are no hard-coded instructions. Everything is learned from data. Now, of course, that in itself sounds very intuitive. The reality is very hard to do, but it's doable. And what's so great about it is it allows for a lot more expression. Because if you have an end-to-end learning machine, that machine can be a lot more creative in the true sense of creativity, which is it can discover its own problems and then solve them. This is our working definition of creativity that we borrow from David Deutsch. So the way we define creativity is the ability to discover its own problems and then solve them. And that can be done by end-to-end. There's a path towards creativity through end-to-end compute. And this is what V12 is offering. The third thing we want to talk about is a statement that Tesla made, which is tied to why end-to-end is so powerful. And the spokesperson said that, quite frankly, I'm quoting, so I'm paraphrasing, now quoting, quite frankly, our main problem is not even talent or getting the best researchers from Berkeley or Stanford. Our main problem is compute, as simple as that. And the reason it's compute is because, I guess, they said something along the lines of, well, look, we have the models and we have the data. Now it's crunch time. And that's very good news for us, because that means that Moore's law is kicking in, and Moore's law works. Moore's law is a good thing. Moore's law is on your side. Any investor that, if you're invested in a company that tells you, look, the difference between success and failure for us is just Moore's law. Like if you have time to wait for Moore's law to kick in and does its thing, which is whatever, every 18 months, double compute. If you have that time, then we should be able to grow with Moore's law. Now, maybe it's obviously not the same thing. Not every Moore's law translates into that kind of growth for, let's say, a company. But my point is, look, Amazon took advantage of Moore's law. Microsoft is taking advantage of Moore's law. NVIDIA is taking advantage of Moore's law, actually driving Moore's law even faster because of things like sparse compute and things like that. So if you have Moore's law on your side, you're up for some sort of growth. Maybe not exponential, but definitely a lot more than some pedestrian GDP plus type growth. This is the good news. Very, very exciting. Probably the most exciting comment that he made. And lastly, I want to just say that the purpose of this podcast is to give people a sense of what it feels like to run a hedge fund. And I think this is a beautiful example now of how hard work pays off. Because, look, we're losing money. We're down 18.5% for the year. It's a terrible start of the year. But we couldn't be more excited right now. Why? Because we had this call. And this call actually reiterates our commitment to AI and Tesla. And the reason we're able to make that statement is because we've done the work, is because we've actually, it's because we're able to ask the right questions. Observations are theory law. Like our theory of Tesla, or our thoughts about Tesla and AI, are based on our observations, which are based on our knowledge. The fact that we know how end-to-end might actually work, how end-to-end is being implemented in the real world, in the science community, gives us confidence that Tesla can do it, will do it, and will succeed. Because the more human-like a Tesla car drives, the more it will be adopted, the sooner we'll see margins accretion through software in the company, the faster the re-rating will happen, and the faster our wealth generation will continue with Tesla. Thank you.